I think we'll go ahead and get started here today. My name is Jonathan Lockwood. I'm a STEM training and development specialist with Boxlight. Been with Boxlight for about 2 years now. Prior to that, I was a classroom teacher at the high school level for about 8 years. And today we're going to be really talking about how we can utilize robotics to teach critical thinking. So we all know critical thinking is a very foundational skill in the classroom and especially in STEM. So we're going to focus today on how coding with a robotics product, such as the MyBot Recruit, can actually enhance students' critical thinking abilities. So to start out, I'm going to start us out with the poll here just to get an idea of who is with us today. But if you want to go ahead and take a moment to answer this Zoom poll, so select any things that apply to you, so both grade level as well as subject area. I'll give you just a little bit of time for that just so I see who's joining us today. Maybe I can cater some of my examples specifically to some of our grade levels and subject areas that we have with us today. Okay, so great. I'm going to go ahead and end this poll. So as expected, we have a lot of high school science teachers with us today. Most everybody here is a high school science teacher. So that's good. You're with the right person. I'm also a former high school science teacher. So hopefully I can share some things that might connect with your class. So we're talking about critical thinking, and critical thinking has been broken down into 5 stages or steps. And the definition of critical thinking is the ability for students to objectively analyze. So objectively means that they're taking into account their own experiences in that analysis, and then to evaluate some issue and form their own judgment. So critical thinking is going beyond just finding the right answer, but we're digging a little bit deeper than that and looking at ways that we can improve the answer or maybe give a more complete answer to a problem. And these stages that sort of work through critical thinking are given here. We have the observe stage, analyze, inference, communicate, and then problem solve. So we're going to talk through these 5 stages today and how they connect with robotics specifically. So in our very first stage, we're talking about observing. So when we are observing, this is sort of the initial step into critical thinking. And this is where we're just understanding the task that needs to be accomplished and asking those critical questions, right? So when we look at this in a coding mindset, right, we're thinking about maybe what tasks our robot needs to accomplish, where the robot needs to go, is there a specific way that robot needs to do that? So maybe if we're having our robot navigate a city, does it need to know if there's stop signs at this city? Does it need to know if there are one-way streets in this city that it needs to consider as it's navigating? Right. So this is where, as we're observing, we're asking as many questions as we can think of, because as we observe and we ask those questions, that's what sort of builds that ability to critically think and to try to create as complete of a solution as possible. In our next stage, we're analyzing. And so analyzing is where we go back and look at those questions that we had. So like I mentioned, we're talking about things that our robot can do. And I'm going to continue to use this city example. So I'll give a little bit more description to our city example before we continue here. So I have my MyBot Recruit here. And what I want to do is the challenge or the goal is for my MyBot to be able to travel through an entire city and stopping at specific locations of interest. As it travels through that city, we are looking at things like one-way streets, stop signs. Is it going to stay on the road? Right. So if our city has roads, we need that robot to follow that road in some way, using some of the sensors on the robot, maybe using a color sensor to do line following or an optical distance sensor to keep it from crashing into buildings. All right, so after we've asked those questions that sort of define the task at hand, in this case, having a robot navigate a city, analyzing is where we're going to take and dig a little bit deeper into those questions and find out what might be a complicating issue with approaching any of those specific questions that we came up with or challenges that we have to overcome. So these are things like understanding how the sensors on the robot work, right? So as you're learning how to use the MyBot, you have to have an understanding of what these sensors do and how they operate. So looking at using a color sensor to do line following, right? So to do something like that, we would start out with like a very simple foundational process where students are just learning how the sensor reads in data and learning how we can take that data and then create some sort of logic that keeps that data from the sensor within a certain constraint that would allow it to stay within that line, right? So in the case of this picture here, we might want that robot to follow that white line. And on the bottom of our MyBot, we have a color sensor. So we want that sensor to adjust the direction the robot travels if it starts to read something other than a white. So if it gets into the black area, right, it's going to correct the course of the robot to stay within that line as it's following. All right, so analyzing, this is where we're looking for these challenges to overcome. And in this step, this is where coding sort of starts to branch out, right? When we're observing what the task is or what the challenge is, most students always end up with the same questions or the same concerns as they're understanding the assignment, understanding the challenge. When we get into the analyze phase, this is where we start to see students really step into critical thinking. This is where students are going to start to formulate their own ideas based on the task at hand. They're going to find their own things that they might consider to be a challenge. Right? Some students might understand how to use the optical distance sensor to keep the robot from crashing into objects. Some students might choose to see that that's not even an issue at all, but that the robot might have a challenge navigating a one-way street, and how understanding how the robot is going to understand a street might be a one-way street, or finding a stop sign and understanding how a robot might understand how to stop at a stop sign. In our next stage, our inference stage, this is where we start to formulate solutions, right? So we're thinking about ways to overcome these problems. So we began by finding the problems, right? Asking all these questions, trying to figure out the challenge as completely as possible, right? Then we analyzed those problems and found out how those problems might challenge us. And then we're looking at inferencing. So how do we formulate possible solutions to overcome these problems? And this is where, in critical thinking, we get a real collaborative approach. Right. So in this inference stage, this is where students can actually start to play around with the coding interface. So the MyBot, you can do Blockly coding or you can do Python coding. So this is where students can start to jump into that interface and uh, start to find small bits and pieces of code that might be used to overcome some of these challenges that were previously identified. And this is a great stage for students to be collaborative. Some students might have different levels of experience in programming, depending on what style of programming you're doing, whether you're doing it with blocks or with text-based code. But this is a great chance for students to teach other students how to do things, for you as the teacher to sort of step back and let the learning organically happen. Because what's great about coding, and we're going to talk about this coming up, is there's not necessarily one single correct answer when it comes to creating code or programming a robot to accomplish a challenge. Right? Students are going to find ways to do things differently, maybe do things in a more succinct fashion, and really focus um, on improving and enhancing the challenge by creating and improving their code. Right, so this inference stage is, again, really focused on starting to formulate those solutions. Yeah, so I see Hannah in the chat, right? Great place for formative assessment, right? This is where you can start to get students conceptualization of the problem, but also a great place to start assessing them on specific skills within coding. So learning how to see if students understand rather how to utilize logic, how to utilize sensors, how to utilize if statements, how to utilize loops to repeat code if code needs to be repeated, right? And those are some of those like foundational concepts in coding that we talk about as we're teaching programming with our students. Right, continuing with that collaboration, we want to move into communicating. Right? A big part of coding is not necessarily a solitary um, practice, right? Sometimes when we're doing math in the classroom, right, students get a worksheet, everybody works on their own on that worksheet. I really want teachers to think against doing that. When you get into coding as a profession and programming and creating code as a profession, it's seldomly done as a solo venture. Um, Programmers often work on very large teams where each person might be responsible for a small piece of the code or the overall, program. Um, but there's levels, there's checks and balances within that, right? When somebody finishes a piece of code to accomplish a specific task, then they pass it along to another person in that team who gives feedback, who suggests improvements, right? And that's what we're thinking about with this communicate stage. So once students have sort of built these modules to accomplish some of those tasks, right now we're asking students to communicate and share and seek feedback from other students in the class. Right, so they might have built a small segment of code that allows the robot to follow a line, and then they need to pass that along to somebody else to seek feedback. And when they're seeking that feedback, right, we need to think about ways to do that effectively and to do that in a positive manner. Right. So students need to be in the mindset that their code is not going to be perfect on the first go around, but that they're looking for somebody to find faults in what they've done and ask for ways to improve it. Right. So I often, try to structure one good thing, one bad thing, right? So students are thinking about here's a really cool thing that I didn't think about I could do with this specific program, and then give them, one area for improvement. So there's tons of different ways that you could structure that process with students, and it really depends on the grade level of students too. High schoolers, I saw we had a lot of 9 through 12 teachers in the chat today. High schoolers are a little bit more receptive to feedback than maybe our middle school or elementary school students. But having a process really is important for giving that feedback, so we can do it in a positive way. And then we get to problem solving. Right? After getting that feedback, on the code that's been created, um, we start to find out that there's not one way to do this. Right? As students communicate with other students, communicate with the teacher, they're going to start to find that there's not a single path to a correct answer, but that the correct answer is just being able to accomplish the task. Right? This means that there's many different ways you can iterate and improve that code and make it more and more robust. Right? So going back to that example of our robot navigating the city, right? If we only program our robot to do the bare minimum, following a line through the city, stopping at stop signs, right? We don't take into account other factors, right? What if we put two robots on the map, right? What's going to prevent the two robots from crashing into each other, right? What if the city decides to paint their streets so the streets are no longer white and they're a different color now? How does the robot quickly learn and adapt to that? And so once you get to a correct answer, right, there's never the end, right? We're always looking for ways to iterate, improve, and test that code. So as students are getting to what they think is the end, right, and they test it and they have something working, that's where you as the teacher can step in and give them I call it the what if sort of statement, right? What if this changes? What if this changes? Right? And get them to think about ways that they can take their code, their program that they've written to the next level. And that process can sort of be endless, right? You could start an entire class and just build and build and build and build and build just by asking, what if this happens? What if that happens? And you can get really, really complex code. but that code is built small segments at a time. Right? So when we're doing this, it might seem overwhelming at the very end when somebody goes back to look at it. But if you start by segmenting the work, having students focus on small snippets at a time, right, that's really going to allow them to go through this iterative process where they're able to test and improve the code and make that code more robust. So before we talk a little bit about some of our STEM solutions, I'd be curious to hear if anybody in the call today has actually used coding so far to enhance lessons in their classroom. Maybe you're not a computer science teacher, but you're using coding in some other way. Or maybe you are a computer science teacher and you're actually teaching coding directly with your students. I'll give a couple seconds here to complete this. All right, great. So it looks like we're about 50-50, actually almost perfectly 50-50 with everybody who's with us today. So for those of you who have not used programming in your classrooms yet, right, I really encourage you to think about ways that you can do that. Right? Maybe your class is not a programming class. That's totally fine. But there's ways that we can utilize programming to automate some specific processes in the class or use it for students to have an extension activity to improve what they're actually doing as part of your class's curriculum. So I just wanted to share real quick what Boxlight offers as far as STEM products. So we have three primary hardware products that create one of the most robust and integrated STEM solutions available in the K-12 classroom. Those products are the MyBot Recruit, which we sort of talked about today. We have a 3D printer, both the large and small size 3D printer that allows students to do a lot with design thinking, 3D design, and even creating manipulatives for your lessons in your classroom. And then finally, we have the lab disk, which is our all-in-one science lab that is a bunch of sensors built into a smoke detector sized device that students can take, collect data, and analyze that data with very high precision and no calibration needed. And then the most important thing to me is our curriculum platform. So for all of our products, we have a full suite of curriculum that's available for all of our students and teachers, of course, to use. So I wanted to keep us right on our 20 minutes today, but I will invite you to join us next week. Next week, we will have Preston with us. Preston is going to be sharing some of his experiences as a classroom teacher in the K through 5 classroom, specifically relating to the social and emotional uses or applications of 3D design and 3D printing. I've already seen a little snippet of his presentation, so if that is the age group you're working with, K through 5, I think this presentation that he'll be giving will be extremely beneficial to you and your students. So I invite you to join us next week at the same time. And with that, we are done for today. So if we have any questions, I would encourage you to put them in the chat. Otherwise, thank you for joining, and I hope you have a great rest of your day. Great, thank you, everybody. And if you want to look back at today's session, we are recording it, so we'll send out a recording following up with today's session, and also an invite to register for next week's session as well. Thank you, everybody.